And the only topic that is left in this chapter, that is chapter of force, density, and pressure. Chapter number 4, basically after dynamics. So that is the topic of Archimedes principle.
Okay.
Basically, this principle is very much basic because you already know about the density and you know about the upthrust or the upward force applied by the water. So basically, if we want to write the principle stated by the Archimedes, so it is for the object that usually float on the water or the object that sinks into the water. So it states that an object submerged in a fluid at rest has an upward buoyancy. Buoyancy means it simple means of it is a force that is known as upthrust, right?
Yeah, so buoyancy is like the floating,
Yes.
right?
So we are using buoyancy force in the place of the upthrust equal to the weight of the fluid.
So it's like perfectly floating.
Yes. Displaced by the object. So in simple words, we use a Newton third law for the solids, like when one force is acting in downward direction, so the normal reaction will act in upward direction, that will balance the forces, right? So same goes for the liquid, but in liquid, we know that liquid can flow, molecules are not tightly packed. So that's why we have to use a new principle or different principle for liquid. So that is the case. So that's why we use Archimedes principle, right?
Yeah.
And further, if you want to write the equation, so already will be given in your paper that we already discussed in the last paper. We found that the equation is mentioned in your paper. So that is related to the buoyancy force or the upthrust. So basically that F is equals to rho G into V. V is the volume. This is for the upthrust. Density. So these are the factor included in your equation, and these factors are not much very difficult. We already know about all the factors, so we can easily identify and we can easily use the formula related to the upthrust force, right? And let's suppose if we consider the example of a ship, let's suppose. So basically what actually happens over here when we are talking about different forces. So in this situation, we know that one force is going to be applied by the water in this direction, that is known as the buoyance force. And if we talk about the second one, so second one is going to be act in the downward direction, which is the weight of the body, right?
Yes. Also, is like the gravitational force is like
Yes.
part of the weight, right?
Yes, we can also say that it is equals to, because we know the formula W equals to mg, so we use the same concept. And the third one will be the displaced water, so that will push the ship in forward direction. But we are only talking about the upward and downward force, so both are equal. So when both forces are equal and opposite, so you know that object will float, right? And when weight is greater than the upward force acting on the ship, that is the buoyancy force, so object will sink, right?
Right. Because it's like the resultant force.
Yes. So you can just take the reference from the resultant force. If both forces are completely equal and opposite, so object will float. Otherwise, it will sink into the water. So this is a simple equation related to the Archimedes principle, and this is the statement of Archimedes principle, right?
Yep.
Okay. So basically,
There's
this
this pattern I saw for Archimedes principle, and I wanted to solve it. But
question related to it.
yeah, let me get it out.
Do you have any question that you want to solve?
Yeah, I wanted to solve this one question. Let me find it quickly. It's like in the recent years. Yeah, okay. It's May June
Hmm.
2022, paper 2, variant 1.
Paper 2
Should I
variant.
should I read the question to you? Because it's just like a part and
This is the paper,
question.
right?
Yeah, it's question number 2, part C, and yeah,
This is the question.
yeah.
Okay. So in this question, the sphere in B is now immersed, okay, in a container as shown in figure. And what we have to find out, the density of the liquid is 1100, okay. So density is given and the upthrust acting on the sphere due to the liquid is 2.5. The magnitude of F is unchanged. The value of F is unchanged. So that the horizontal rod is not in equilibrium. Okay, so horizontal rod is not in equilibrium. Use Archimedes principle to determine the radius of the sphere. Okay, so we have to use the Archimedes principle to find out the radius. And we know that upthrust will act in this direction, right? And one more thing, that in this question, there is a concept of moment included, right? Because you can see there is a pivot point given over here. So we also have to use that concept. So there is a mixture of concept, right?
Yep.
So basically, not in equilibrium means that
Means
clockwise
it,
rotation is not equals to clockwise rotation, right?
or it's like not in a closed system.
Yes. So basically, if we use the basic formula of the upthrust, so this is the equation for that. And with the help of this, we can first find out the volume, right?
Right.
So volume will be equals to 2.5 divided by density into 9.81. So what will be the final answer of volume?
Let me calculate it.
Right? So this will be the answer for the volume.
Yeah, it's 2.3 multiplied by 10 to the power of -4.
And the main theme is we have to find out the radius, right? And you know that we are using a sphere. We have
So
to
it's
find
4
out the radius of the
10.
sphere. So 4 over 3 pi r cube, right?
Yes.
So you have to use this equation to find out the radius of the sphere, okay? With the help of the volume.
Okay.
Yeah.
Yeah, let me just write this down first. It's like the paper's right in front of me. And it doesn't matter, the pivot doesn't matter right now, right? So
Yes,
like in
because for this part, yes, for this
part
part
two
it is
will
not
matter now.
important. Might be next part related to that, yes, because in the next part they are asking about the direction of the resultant moment. So in that part it is important.
Okay. I'm done
So,
writing it.
okay. So are you going to solve the second part also, or you may do it by yourself?
I can do it by myself.
Okay. So try this question by yourself. If you don't find the correct answer, so let me know. And for now, we are going to start one more paper, that is your latest May June 23 paper, right? 2023 May June paper 2 variant 1.
Okay.
So in this question, let's see what are the question. Now we know that from the start we are also able to solve the question, from the end we are also able to solve the question. So from which part you want to start, for the first one or from the wave section?
Let's start from the first one.
Okay. So this is your first question, very first part. So first part is very simple. It is related to the definition part.
Okay, so power definition is uh the the work done per unit time or the rate of work done.
So first part is very basic, and the second one is use the definition of power to show that the SI unit of power are kilogram meter square per second cube. Okay. So basically they are talking about the SI units. So we have to drive according to that. If we use the formula for power, W over T, and if we further split the formula, F into D over T, and further if we simplify it, so it will be F is equals to MA D over T. Now all quantities are very basic, and we can easily write the SI units of all quantities. So it will be equals to kilogram meter per second square for acceleration, meter for displacement divided by second for time. Okay. So you can see
Okay.
that it will just multiply with the meter, kilogram.
Did this question.
Yes.
I think I did this question. or something similar to it.
Yes, might be similar because this is the latest paper. So you know that questions might be repeated or like slightly different question. Because
Yes,
in
I
first
I
chapter,
solved I
hmm,
solved some past papers the other day from 2021, and
hmm,
there was something similar to this,
yes. Because we
the
also got
derivation.
one question like this when equation is already given and you have to prove the unit also. So for in first question or first chapter, you will find
Repeated this because I remember it was past.
yes. Okay. So part B is related to intensity and the formula of intensity is already given. All units are defined because we know it is related from the first chapter. So we are not going to write the formula by our own. And the question is determine the SI base unit of K. So basically
Okay,
you
so
hmm,
we have to use
the
so we're
same
gonna do this frequency. So lambda is 1 divided by 2, so it's gonna be like s minus 1 is the unit.
okay. And from the equation, if we just shuffle the value, so you will find formula like this for the value of K.
Yes.
Okay. And for the intensity, so for the intensity, you have to write the SI unit of intensity. So if you remember the formula of intensity, what is the basic formula of intensity?
It's
Power per
watts
unit meter.
per
Yes,
hour divided by meter square.
yes,
So we're gonna use the kg meter squared SI, like we're gonna use that power
yes.
divided by meter square.
So
Because
since
I
you
remember I was doing the
mhm,
second question and then I used the power original formula first and it wasn't working. So then I used the derived, the one with that one.
okay. So if we first write the original units for the intensity, so this is the complete SI unit of intensity only, right? Divided by F is the frequency, and for frequency, you know the formula that will be equals to 1 over second, right? Because frequency is equals to 1 over time. So the SI unit will be second inverse. Okay.
Okay.
So there is a square of frequency. So it means S minus 2. We are having a quantity of area square. A is the amplitude. Amplitude means length. So it will be equals to meter square. And the final is V. V is the speed. So meter per second. So these are the SI units according to the situation. Now we just need to simplify it and we will get the final answer. So let's see which quantities will cancel out. This will cancel out. And finally, you will get the units. Kilogram per second cube divided by meter cube per second cube again, right? So again,
Right.
cube will cancel out of the second. And finally, we got kilogram per meter cube, the final answer.
So the base unit, the SI
For-
base unit
Yes,
intensity of K,
it's kg
the
per
con.
meter cube, right?
Okay. Yeah.
So this is the concept and this is the first question. So that will be
Wait,
very,
isn't
hmm,
cube density? Isn't kg per meter cube density?
yes. So basically that K is the density. Okay.
Okay. But they just said it's a constant.
Yes. Because in chapter one, you know, we are only working with the quantities. We are not working with the
Right.
exact concept related to any physical quantity. Okay. Question number two is like a typical one. Let's see what they are asking. A rigid uniform beam of weight is connected to a fixed support by a hinge as shown in figure 2.1. So here is a hinge and the other side is connected with the spring. Load is also placed over it. Okay. And there are values given in total force of 8.2, vertically upward direction. On the horizontal beam, a block of weight. This is the weight of the block. And the right hand side of the beam is connected to the ground by string at an angle of 30. So string is connected at angle of 30. The tension is 4.8. The distances along the beam are shown in the figure. The beam is in equilibrium. Okay, so we are able to use the law of principle of moment. Assume that hinge is frictionless. Okay, no friction include. Show that the vertical component of the tension in string is 2.4 Newton. Last time we also used solve. Mhm. We also solved some type of question last time, right? The vertical component only. So basically, if we consider the string, so this is the horizontal component, right? And this will be the vertical component, okay? And it will make again right angle triangle. And they mentioned that the tension in the string is 4.8 and it is at 30-degree angle, okay? So basically the tension in the string is 4.8. So we have to find out the vertical component only. So the vertical component for the tension will be equals to Ty is equals to T sine theta. And for horizontal component, we know that. Remember that formula from the Pythagoras theorem and right angle triangle.
Yeah.
So basically we have to find out the vertical component. Question is for 1 mark. So we know that we just simply need to use the formula of Ty is equals to T sine theta.
I think I did this question. I feel like.
Yes, basically some setups are the repeated ones slightly. There will be change. So questions are like that we already did that question, but that part we already did in some other question. So that's why we feel that we already solved this question. So basically force is or tension is 4.8, angle is 30. So your final answer will be equals to 2.4 Newton. Okay. So 2.4 Newton is the answer for the vertical component of the tension. And in the second part, by taking moment about the hinge, determine the weight of the beam. So the second part is related to find out the weight of the beam, right? So what we need to do, we have to now apply the principle of moment, the clockwise rotation, the anti-clockwise rotation. So let's try to find out all the forces. So the very first step is to identify the forces. So one force is
Right.
acting in upward direction, that is applied by the spring in upward direction. So rotation will also be in the upward direction like this. Okay. And if we talk about the other forces, so one force is already here, W. So it will rotate like this, okay, like clockwise. And second object is placed over there and the value of force is already given. So it will also move that rod in downward direction. Clear? Any confusion?
No, no confusion.
And one more thing, we find out that the tension, the vertical component which is acting in downward direction. So that is also included now,
Which one?
this vertical component, because we find the vertical component, right? So that is
Yeah.
also a force. So that force is equals to 2.4 Newton.
Okay.
So it means now we are having three forces acting in downward. Okay. It will also move in clockwise direction, right? So basically we are having three clockwise rotations, clockwise, 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 and one anti-clockwise. So we have to use the formula of principle of moment. So anti-clockwise rotation is only one. The value is given by the force exerted by the spring is this. So let's suppose if we consider this one as F1, right? So three on the clockwise direction and one on the anti-clockwise. Okay.
Okay.
Force is 8.2. And what is the value of the moment arm for force one?
Force 1, it's 8.2.
The moment arm. 8.2 is the force. And what will be the moment arm?
Yeah, the distance is gonna be
0.5. Because
right because the
5
spring is the
is
one which is exerting.
and if we talk about the remaining factors, so we know next factor is unknown. So we write W, and what is the distance? 0.5 plus 0.10, that is equals to 0.60. Okay, because we need
Okay.
to take the complete distance like this. And the third one, 0.30, and we have to plus zero point 0.2 again, so it will be 0.8, right?
Yes.
And the final force will be 2.4. This will be D4. So 2.4,
Okay.
0.0 plus 0.40, that will be equals to 1.20, right? Got it?
Yeah.
Okay, calculate the final answer and let me
What
know.
I'm supposed to do 8.2 multiplied by 0.5, and then I'm gonna subtract the rest, right?
Yes,
And then I'm gonna divide it by 0.6 later on.
yes.
Okay, the answer I got was 1.6.
The final answer.
Yeah.
Okay. Okay, so we solved the second part of the question, and your answer is 1.6 Newton, the unknown weight. And in the next part, calculate the horizontal component of the force exerted on the beam by the hinge. So basically, first we calculate the vertical component, and they are asking about the horizontal component. Okay, so for horizontal component, you know what we need to do? We already write the formula over here.
So
So
we
that
need to do the Force equals to 4.8 cos 30.
Yes. So your x component will be equals to,
Also, it's 4.2 Newton, the answer. Final.
okay. So we are getting 4.2 as the horizontal component. And next part is the spring obeys Hooke's law.
Like, okay, so instead of using like k equals like f equals kx, we're gonna do e equals half fx.
Okay. So we use the concept of energy that is equals to,
Yeah, because energy is 0.32, they gave it to us. So we're gonna do 0.32 equals half multiplied by the force, which is 8.2 newtons, right? And you multiply it by x, which is the unknown, and then
hmm,
you rearrange it to find x. Like you multiply it by 2 and divide it by 8.2.
yes. So you will get your final answer. That will be equals to 0.07,
0.7.
or we can round it off to 0.08.
Okay. But shouldn't we have like two significant figures?
Yes, yes, yes. We have to write two significant figures. So we have 7, 8. Right. So this is the concept of second question, right? Uh,
Yep.
there is part C also of this question. String is cut so that the spring extend upward. This caused the beam to rotate and launch the block into the air. Now you can understand what is actually happening, because from the corner of the rod, it is tied with the string. And when you just cut that string, so it will act like that catapult machine, right? If you just place the ruler at the corner of the table and just you apply force on that ruler, and object is placed on the other end of the ruler, so that will move like projectile. Okay. Or if you take the example of seesaw, if one side of seesaw in upward direction or second one is on the ground level, and
Oh,
you
I
just,
understand.
yes, so you just
So it's gonna be the gravitational potential energy.
yes. So basically, by performing this experiment, you will get the rotation or the diagram which is mentioned in figure 2.2. So this is the path of the body that is covered by the body during this motion. So this is the diagram. And during this diagram, they mentioned that the height, the block is at a height of 0.09 meter. This is the height of the block above the ground when it is passes through point A. The next is the block has a kinetic energy. So we are having kinetic energy when it is hits the ground at point B. Air resistance is negligible.
Is air resistance always negligible in our exams? To like
Yes,
make it
because in projectile motion we discussed that this is the assumption, so we have to consider that one as
yeah.
negligible.
Okay,
So
so what we're gonna do is we're gonna do energy equals mgh.
okay,
So it's gonna be we already they gave us the weight though, right?
weight of the body.
So weight is the same thing as mg.
Yes. Where we calculate the weight? 1.6.
No. Wait, go up a bit. Isn't it? It's
0.3. Yes,
0.3, right? 0.3.
is the weight of the block.
Mm-hmm. And then the height is given there or not?
Height is the block is at a height of
0.0.
0.09.
So you multiply it to get, you're gonna get 0.027 joules.
So this is the answer of the gravitational potential energy. And next is use your answer in Parsi 1 and conservation of energy to determine the speed of the block at point A. So we have to calculate the speed of the block at point A. So any idea how to use that term?
Yes. Yep. We're gonna use the formula
Hmm.
E equals to half mv square.
Yes, because we know potential energy is equals to kinetic.
Yes, because it's the conservation of energy theory, like GPE equals to KE. And we know that the energy will be from before it's 0.044, right? So the decrease was 0.027, so 0.044 minus 0.027 is gonna give me 0.017,
Okay.
and then we rearrange the formula.
So 2 will multiply.
Yeah, so it's gonna be V square equals to 2 multiplied by 0.017, which is the energy, right? And then we're
Yes.
gonna divide it by the mass, which is 0.3 divided by 9.81, because 0.3 was the Newton weight. It was weight.
Yes. And we know that mass, we already know the value of mass. We just multiply it and taking the under root. So that will give you the final answer of the speed. Okay.
The speed is 1.1 meter per second.
So answer of the speed is 1.1. And there are two more parts. By the reference to the block on the to the force on the block, explain why the horizontal component of the velocity of the block remains constant. We already discussed this concept because air resistance is negligible. So your resultant force will be equals to zero in horizontal component only, right? Because that is the assumption of the projectile motion, that horizontal component will always remains the same. So they are asking by reference to the force on the block, explain why the horizontal component remains the same.
Okay.
Moves from point A to B. So you can see from point A to B, there is no air resistance. So it means resultant force will be equals to zero. And the last part,
The last part. Okay, so we have to draw a graph
yes,
showing the. Okay, so you're gonna give it's gonna be a straight line with like, so it's constant acceleration, right?
mhm.
And you're gonna start with at not zero because it's already having speed.
Okay, so block passes through point A at time t is equals to A and arrives at point B at time t is equals to TB. Okay, on figure, sketch a graph to show the variation of the magnitude of the vertical component Vy of the velocity
Wait,
of
can I do this with the zoom? Yeah, I can draw on this. I drew on it. Can you see my drawing?
yes,
So like that's the line. It has to be straight.
yes. So there will be a straight line, that is the graphical representation of the motion of object from TA to TB, right? So this will be the graphical representation. Okay.
Okay.
So this is the question. I will share this paper with you. You may try the rest of the question by yourself.